All right, so for 4-7, we're doing absolute value inequalities. Last time we did equations, and now we're looking at inequalities with these. Okay, so our objectives, we're going to solve some absolute value inequalities. And 2, we're going to write and solve absolute value inequalities that will model real life. Okay, so using those word problems, which continue to be the struggle. All right, so remember, absolute value is the distance from the origin, and the origin is 0 on a number line. So if we look at the absolute value of x is less than 3, how would we graph that? Start at the 3, Open circle because it's not equal to. Good. And
then we would go
left. Okay. All right, very nice. So how about the next one? When we have closed circle at 3 again. This one says greater than. Well, you said go right again. Last time we went left. So do you want us to go? So you wanted us to go right or left? Right? Okay. Okay, is that all? We're good with that? No. Do what? Because it's the absolute value. That's where it gets trippy. What did we have to do last week when we had the absolute value? Cameron, can you take your hat back off, please? We had to split it. Remember, we had to split it to be a negative and a positive because the number inside here can be a negative or a positive. So x can be less than 3 or x can be less than negative 3. Okay, so then it can be x is less than 3 and x is less than negative 3. But I thought this distance had to be less than 3.
So it's anything. To be honest, I have no idea what you would. I think I know what it is.
Okay, so let's think about this for just a second. Let's break this down. So absolute value is a distance. Right? Absolute value is a distance. That's why we kind of reviewed this definition. It's the distance from the origin. The distance has to be what? What does it say right here? The distance has to be... No, what's it say? The distance has to be less than 3. Okay, so if we would just think about this in terms of what we're saying, the distance is less than 3. So from the origin, we can go this way and have an open circle, and that's less than 3, right? Yeah. We can go the other direction to a negative 3, and that's it. That's it. My distance has to be less than 3. But when we talk about this, again, so we're looking at what number can be in here. Well, x can be less than 3, which is what we've got, or it's going to be x can be greater than negative 3. What was the rule with inequalities before? When did we flip the sign? When we multiplied or divide by a negative, okay? And that's what's happening here, is when we put the negative into it, we have to flip the sign as well, just like we did before. So when we're writing these, when we did absolute value equations, it didn't matter because it was an equation. But that same thing applies, which why I have my watch the signs here, because when we put the negative in there, the sign matters. We have to flip the sign. Okay, now this one, again, we're looking at the distance has to be greater than or equal to 3. So x is going to be greater than or equal to 3. Great. That's the one you graphed. What's the other version? Okay, so x is less than or equal to -3. Good. So at -3, I'm going to fill it in like Bailey told us to, and it's going to go left or right. I was like, always look at your arrow. The arrow is pointing to the left, so we're going to go to the left. So absolute value inequalities, when it comes to that flipping the sign, like when we split it into two parts, we have to flip the sign too, just like we did when we had negatives earlier. The cool thing is when we have a less than, it's always going to look like this and be everything in the middle. When there's the greater than sign, it's going to be going the opposite directions because the distance is greater than this. Okay, which means these with a less than, okay, so it's any number whose distance is less than 3 from 0. These are conjunctions. So we can write it as x is greater than -3 and x is less than 3, or we can write it as that combined conjunction with just the one x in the middle. Okay, those can be written because your x values are in between there, so we can write it like that. The greater than ones are always disjunctions. Okay, they're always the or statements when we're doing absolute values. Okay, so that we're going to have to remember that as we move on. Because example 1, we get to get some practice in. All right, so it says use a disjunction or a conjunction to state the solution to each inequality and graph the solution set. All right, so if we split this one, what are we going to split it into?
Half.
Not half.
X is less than -1.
X is less than -1, so we flip the sign. Good. And we could go ahead and graph that. So we've got -1, open circle or closed circle? Open circle. Notice I'm going to graph it above. We're going to see here. Well, you could graph it on it probably. Okay, it goes to the left. What's the other one we're going to graph?
1. At 1.
It's not at 1. I need the whole thing. X is greater than 1. So we have open circle at 1, and it's greater than 1. So here, let me move this one on down. Okay, so we stated the solution kind of, and we've graphed it. The reason I say kind of is we don't have if this is an or an and.
It's an and.
Is the x in the middle?
No.
Then it's not an and. It's an or. Okay, so you can say or here, or you could have used the or symbol. Which one is the or symbol? The V. Okay, there you go. Perfect. All right, let's look at the next one. Abigail, what's one of the expressions for the inequalities here? Okay, x is greater than or equal to -4. Good. And Bailey of Freeze, what's the other one?
X is less than.
Perfect. All right, Josie, graph the first one for me. X is greater than or equal to -4.
Okay, x is greater than or equal to -4. Then -4, you're going to need to put
A closed circle. Okay.
And then greater than, it's going to go to the right.
Perfect. All right. Sorry, I didn't realize your voice was so bad. I would have saved you a little bit. Okay. Cheyenne, how about x is less than or equal to 4? Okay.
You say greater than?
Less than or equal to. Uh-huh. To the left. Okay, so this one maybe I shouldn't have graphed on my number line. So I'm going to move it down a little bit so I can put my actual answer on the number line. So what is my actual answer here, Abigail? -4, do you say 2, 4? Yeah, right? Because it's this part right here. Okay, so how would I write that solution? It's an and, right? So we need an and, or we could say x, okay, x is greater than or equal to -4, and x is less than or equal to 4. Okay, Cameron, how do I write the combined conjunction for this? With just the one x in the middle.
You would write x. No, you write -4.
So, okay.
And then is less than or greater to?
Less than or equal to? Okay.
And then 4 on the other side. 4 is greater than or equal to x.
Well, I want to write it as a combined conjunction with just the x in the middle.
Yeah. You would just do.
So I've got -4 is less than or equal to x, which is, you want me to write a greater than sign here? You said 4 is greater than or equal to x.
No. You flip the sign.
Okay. So what sign goes there?
X is less than or equal to 4.
Perfect. Okay. Because one of these is going to stay the same. Like this one, right, x is less than or equal to 4 is the same as what we just wrote. This is the one we flipped because we needed the -4 to come first. Just like when we graph it, we always want the x to come first. When we write it as the combined conjunction, we need the number to come first. Okay, very nice. Example 2, then we need to solve and graph the solution set. Again, this is what we did on Thursday. What has to happen before we split the equation?
You have to get an answer.
You're close.
Switch the sign.
What'd you say?
Absolute value.
We have to get the absolute value alone. Okay, so in this one, right, we have absolute value. There's no other, it's not like 2 plus the absolute value or the absolute value minus 7. We have to get rid of all that stuff and isolate our absolute value, okay, before we can split. All right, so then we split it. X plus 5 is less than or equal to 10. And then x plus 5 is greater than or equal to 10. We had to flip the sign. Solved both of them. Subtracted by 5. So we got x is less than 5. So we have 5. It's less than or equal to, pardon me. And so then we graphed it. And then we got x is greater than or equal to -15. So closed circle to the right. Okay, we have this overlap area. So our solution is just this area. And so that leaves us with our combined conjunction. The -15 is less than x, or less than or equal to x, is less than or equal to 5. So, questions about A? Okay, I have it shown there so you can see it pretty quick. Let's do B and put it into practice. Okay.
So say it was x plus 5.
We'll get to some of those.
Like if there were two things on, if there were two numbers on each side, so say it was like 10 times 5 on the, for example, the equation was x plus 5 is greater than 10 times 5 in absolute value. Would you make both numbers on the other side negative?
No, you would solve them, I think. Let's get to some because I don't know. Yeah. Okay, so is this one ready to split into two parts? Is the absolute value isolated? Is there anything else with the absolute, outside the absolute value? No, so it's ready to isolate. Okay, so Cheyenne, give me one of the equations. Less than -18. All right, good. All right, very nice. Bailey DeFreeze, give me the other one. Okay, so one is identical. The other one we flip the sign and make it negative. Okay, Josie, what's the first thing we're going to do?
We're gonna subtract 6 from.
Perfect. You can just say subtract 6. I'm good. Your voice is strained. So subtract 6. So we have negative 3x is less than, what's negative 18 minus 6?
That's a good question. 12.
Nope, because they're both negative, so it's going to get bigger.
20.
Negative 24. Perfect. Okay. Abigail, what's next? Divide by negative 3. Ooh, I'm dividing by a negative. What do I have to do? Flip the sign. Okay, good. So then I've got my negative 3's cancel. X is greater than, what's 8? A positive 8. Perfect. Okay, I don't have much room there to graph, so I'm going to graph it below. X is greater than positive 8. So open circle. Because the negative 3 was inside. The thing that changed was the negative 18 outside. Yeah, the negative 3 was inside, so we had to take that. Good question. All right, x is greater than 8, so it's going to go open circle at 8 and to the right. All right, so let's look at the next inequality. Negative 3x plus 6 is greater than 18. So Cameron, what's the first thing we're going to do there?
You would
subtract the 6. Okay, so we've got negative 3x is greater than, what's 18 minus 6? 12. All right, Bailey Malin, what's the next step?
Now you need to take the 3 and divide it by.
I don't want to divide by 12. That would 12 divided by 12 would give me 1. It wouldn't isolate my variable.
Well, you need to take the x and 3.
What am I? So I'm going to divide by a number. What number am I dividing by?
3.
Okay, that's what you want to say, but it's not 3 either, because this is a negative 3. Okay, I want to divide by negative 3. What do I need to do when I divide by a negative? Flip my sign. So now I'm going to have a less than. So x is less than, what's 12 divided by negative 3? Negative 4. Okay, perfect. And so at negative 4, I'm going to have an open circle, and I'm going to go to the left. So is this a conjunction or a disjunction? Disjunction. Okay. So Chase, what's my answer? Or. So I'm going to say x is. Okay, but give me the whole thing, the whole solution.
So x is greater than 8, funky v, and x is less than negative 3.
Okay, perfect. That is our solution. It's that or statement. Okay, so we know they go opposite directions. Okay, if you all are blowing your nose and we're sick, please go ahead and get up and put your trash in the trash can instead of putting it on the table, because then it'll just be there to pass germs more for others. Okay, questions about this? Are you staying awake, Josie? Okay. I was like, I know the lights are off. It's a little dark. Not feeling the best. You know. Okay. Why are my pages not clearing? So we kind of already talked about this. Be sure to isolate the absolute, or the absolute value is isolated before you write two separate inequalities. So we're actually going to practice that a little bit now, but we're going to get into that word problem phase. Okay? I know, whoopee! Yay! All right, so example 4. Most human muscle cells function well within 2 degrees of their optimal temperature, 98.6 degrees Fahrenheit. Okay, so describe this optimal range of temperature with an absolute value inequality, then solve to find the range. Here's the thing. First, I want you to remember this formula from last week. Okay, to write the equation, we have to have the x minus the midpoint, the absolute value of your midpoint, equals the distance. Okay, but you have to find out like when each, like figure out which each of those is. So in this case, our distance is the 2 because it says it functions well within 2 degrees. So 2 degrees higher or 2 degrees less. That's the distance. The midpoint is the 98.6, like that's the temperature your body should be. So we're calling that the midpoint. And then instead of using X, I'm actually going to use T for my temperature. And I put those numbers into this formula to get out my equation. Okay, so it was the absolute value of my temperature, that's the thing I'm looking at, minus the midpoint. That 98.6 degrees is the ideal. And so it says is less than or equal to 2 degrees. Why did I choose less than?
Because it had. Why did you choose less than?
Okay, is less than going to give me a conjunctive or a disjunctive?
It's going to give you a conjunctive.
A conjunctive, right? Because we want it to say any temperature within this area. So this is a less than or equal to, right? We want it to be any of those. Okay, that has to be a less than or equal to.
Today I left, I was running 102.3.
Yeah, it's a good thing you left. All right, so mine was a 98.2 Friday. Does that help us?
Yeah, you were in
No.
temperature.
Okay, so we solve, split it into two, and solve for T for each one. So we know our temperature in its ideal place for our human muscle to function well needs to be between 96.6 degrees and 100.6 degrees. Because again, our temperature is between those. Those are the exterior, okay, those are the endpoints of our temperature. Questions about how we work through this? Okay, I was like, because we've already done the work, I'm not going to spend it, but I want to make sure you have time to look at it. So you need to look at B and see if we can figure this one out. To reduce storage costs, many manufacturers have implemented just-in-time delivery of the components that are assembled for their products. A car company needs parts delivered within 3 minutes of every half hour. Write an absolute value inequality representing the time of delivery. Then solve the inequality to state the range of acceptable times. Okay, so again, what is the formula that we're going to use? Let's start there. It's the absolute value of x minus the midpoint. Equals the distance. Good. Okay, so we kind of have to work through each of those things. All right. So what do we think our distance or our midpoint is? It's going to be in this sentence. A car company needs parts delivered within 3 minutes of every half hour. Within 3 minutes, so what's 3 minutes? Is it the distance or the midpoint? The distance, within 3 minutes. 3 minutes before or 3 minutes after. So your distance, or D, equals 3 minutes. That's awesome. So what's the midpoint? That'd be the 30 minutes, right? Between every half hour. That would be the 30 minutes. So we can write the formula now. Do we want to leave X? You don't have to change it. It's totally up to you.
Let's leave it.
Okay? All right, so if we take these and put it into the formula, we're going to have the absolute value of X minus 30
is less than or equal to 3.
We want a less than or equal to again because we want it to be within that time frame, either 3 minutes before or 3 minutes after. But so that has to be a less than.
So
Awesome.
Are we gonna have a test on Thursday? Sorry, I'm just thinking about. Our test is on Monday or Thursday.
Probably Thursday. Okay, so it says to write the absolute value inequality. Check, we've done that. Then solve. So we need to do the solving part. All right, so let's see, Cheyenne, give me one expression. Ooh, not if we have less than or equal to. right? If we keep this sign, we want to keep this number, right? Now, give me the other one then. Yep, everything in here, everything inside the absolute value stays the same. You have to flip the sign to make it a -3. Like you need a -3, but then you have to flip the inequality sign. Greater than, good, or equal to. All right, so from there, you all solve each of them, and then you can get started on your homework. I will come around and check your work. Okay, let me pause this.